Welcome to 2017 question A2. It's a Conics question. So the graphic below shows the logo for a Ladies Professional Golf Association. Okay, so here's our logo. It contains a combination of geometric curves depicting the female golfer. So here's our curves. The main curve is a parabola, and the golf shaft is a normal to the parabola. So here they're telling us this is a parabola, and this golf shaft is a normal to that parabola. The drawing on the right shows the axis AA, the directrix DD, and the focus for a similar parabola. Locate the vertex and draw a portion of the parabola. So straight away when we hear parabola, I think my eccentricity is equal to 1. Okay, so PF over PD is equal to 1 over 1. So my distance I measure out is the same as the distance I measure up to find my line of eccentricity. Or, quicker way to think about it, it's a 45-degree line. Okay, so that's my line of EC. Okay, so we want to locate the vertex. Okay, once I have my line of eccentricity with any conic, to find the vertex, it's back at 45 degrees and straight down. Okay, so 45-degree line. Or, because it's a parabola, you could bisect the distance between your focus and your directrix. But it's kind of an unnecessary step. And we can just do a quick line like that. So 45 degrees and down. Draw a portion of the parabola. So same construction for all conics. We want to take a number of lines here. So I'm going to go vertically there. Any measurement out. Okay, you can go in intervals of 1 centimeter if you want, but I'm just picking random points. Okay, and most importantly, we need our lattice rectum. Okay, so that's our lattice rectum. So, where any of these lines hit our line of eccentricity, we want to go out until we hit our lattice rectum. Okay, so that's actually telling me I need to extend this up a little bit further. So, where it hits our line of eccentricity, so where our ordinate hits our line of eccentricity, we draw back parallel to our axis, back towards our lattice rectum. Okay, and we're going to do that for all our points. Okay, actually I'm just going to change this line, bring it a little bit closer just to show you in a clearer manner. This line, that's good there. So these top points parallel back until my lattice rectum. Okay, and the same here, inside, back until I hit my lattice rectum. Then I get my compass, I put the point of it on F, and where those lines hit the lattice rectum, I want to swing back onto my ordinate. Okay, and that is a point on my curve. I'm going to repeat that for the point above. So that is also a point on my curve. And I need to find those points down on the opposite side as well, so I should probably change that. There we have it. Okay, and then for this inside point between my vertex and my focal, right, and find that down there. And finally, where my lattice rectum hits my line of eccentricity, that is also going to be a point on my curve, so I'll just locate that down here as well. So, point, tangential, point, down to my vertex, and out like so. So, free-end curve. Probably could have done with another point inside here. Okay, but that is my parabola. So part A completed. Then we want to locate a point P on the curve which is 30 millimeters from the directrix and construct a normal to that point. Okay, so first off, let's locate that point. So set our compass to a radius of 30, and I'm going to locate a point that is 30 millimeters away from my focus. I can use this point or this point. For the sake of this question, and if we think about what we're trying to draw, I'm going to draw my normal out there. So I'll use this point here rather than down there. So here is point P. Okay. So in terms of locating the normal, okay, we have a couple of different methods of doing that. Okay, I could draw a tangent and then 90 degrees to the tangent, which is a method that I would typically use because the method I use for drawing a tangent is common to all ellipses. Okay, but I'm going to show you both methods very, very quickly. So the first method that I would use is we join P to F. Okay, I'll do this in yellow just to show the difference. P to F, and then I use sliding set squares. Sliding set squares. I'm going to draw a 90-degree line until I hit my directrix. So that's 90 degrees. And if I draw that out, that will give me a tangent. Okay, and then my normal will be at 90 degrees to that tangent. So okay, so that could be our normal there. Right. The second method then, and this is so this construction for finding a tangent to a conic or to a parabola works for all conics. So that's the one I typically lean towards. But if we want to deal with finding a normal only, okay, and we want to use a different method, what we can do is we can go. This works for a parabola only. If I go parallel to my axis, straight there towards my directrix, I'm going to highlight this actually just to show you this is the method I'm applying here. Okay, and if I draw from P to F and I extend it, okay, a couple of things. One, if I bisect this angle, I will get a tangent similar to the tangent I just found. But if I bisect this angle from P to here, okay, that will find me. So just highlight that. Okay, that will find me a normal. Okay, so both of those methods you could use in that question. Okay, it's no harm in knowing two of them. So that was 2017 question A2, a nice conics question, something that kind of typically comes up, being able to draw a conic and being able to draw a tangent or normal to one of those conics.